O Rob obteve o doutorado dele em 1984, na Universidade de Washington, em St. Louis. Ele foi orientado pelo Dr. Alan Templeton, um importante geneticista de populações. De 1986 a 1991, o Rob foi professor do Departamento de Biologia da Universidade de Yale, e em 91 ele foi contratado como curador assistente de entomologia pelo American Museum of Natural History em Nova York. Em 93 ele passou a ser curador associado e em 99 a curador. Ele foi curador de duas exposições: a exposição Epidemic, sobre doenças infecciosas, e em 2001 foi inaugurada a Revolução Genômica, que agora está aqui em São Paulo, e que explora não só os aspectos científicos e tecnológicos da genômica, mas também as implicações éticas, sociais e legais desse tipo de estudo.
I'm a scientist first, but working at a museum, I've had the pleasure of kind of twisting my science into getting the general public to understand it. How much DNA is there in a genome? Well, there's lots. Of those 23 chromosomes that we have in our genome, there are about 3 billion base pairs that make up our genome. And this exhibit was in the hall in New York. It consists of 180 Manhattan telephone books, and that's the number of letters, 3 billion letters, that would be in those 180 telephone books. One of the things that comes out of sequencing all of these genomes is the idea that our genomes are a footprint of life on this planet. They're a continuous record of life on this planet, all 3.5 billion years of life that's existed on this planet. So, for instance, one of the things that was recognized at first was the number of genes that other organisms have in them that are also in us. So if you look at a fruit fly, 36% of the genes in a fruit fly genome are also found in a human genome. And what this means is that there's this continuity of genomes all the way from the simplest kind of life on this planet all the way to the most complex kinds of life on this planet. The Tree of Life is actually a project that's being carried on by lots of different countries, including Brazil. It's, again, an initiative to try to get a tree of life for all of the species on the planet. And one of the really important things about using genomes and DNA to do the tree of life is that they hold the history of life in the genomes that sometimes doesn't come out when we look at organisms. Also, our odyssey to becoming human is really interesting. And it's interesting for, I think, just one major reason, and that is it's been so quick. This is a picture from the American Museum of Natural History called the Walk of Life. And you walk around in a circle, and every step you take represents 75 million years. So that by the time you've walked around the whole thing, you've traversed 3.5 billion years. Turns out that when you get to the very end of this walk, there's a human hair under a magnifying glass. And when you look at the width of that human hair, it represents the amount of time that Homo sapiens has been on this planet. So we have been on this planet an immensely small amount of time. So let's go back to the initial question I asked, whose genome is it? Well, it's your genome. And one of the things that you need to do in thinking about this being your genome is to think hard about it and to learn as much as you possibly can about it. That's what this exhibition is all about, trying to teach people that it's their genome. It's your genome. It's the genome of organisms on the planet. And by studying these genomes and by learning more and more about them, we're going to learn lots of stuff about our place on this planet and about our origins on this planet. And I just wanted to thank you once again for having me here. It's been a very, very fun time to be here. Thank you.